So today we're going to look at something really cool. It's a powerful new way for AI to think and reason, one that goes way beyond just finding facts and stats and starts, actually connecting the dots. All right, so let's start with a bit of a puzzle. Think about this. AI can write poetry, it can write code, but sometimes it just can't piece together information that seems, well, completely obvious to us. So what's going on there? Why does that happen? Well, to really get why, we've got to dive into a super common AI technique. It's called Retrieval-Augmented Generation, or, just RAG for short. Now, it's a really powerful tool, but it's got this one fundamental weakness. Okay, so how does it work? Imagine you're trying to understand a huge, complex story, right? But instead of reading the book, you just get handed random, disconnected paragraphs. That's basically what standard RAG does. It takes all its information, chops it up into these little pieces called chunks, and then when you ask a question, it just tries to grab the most relevant-looking ones. And right there, that's where you start to see the cracks in the system. The big problem is that when the answer isn't all in one neat little spot, this method just falls apart. It's terrible at summarizing high-level themes, and it's basically useless if the answer is scattered across a bunch of different documents. It completely fails at, you guessed it, connecting the dots between related facts. This quote really hits the nail on the head. So, if you ask, what has Geoffrey Hinton done? The AI might find one chunk that says, Hinton worked at Google, and another one that says, Hinton is associated with the University of Toronto. It doesn't put them together to tell you the full story of his career. It just hands you these two separate, disconnected notes. Okay, so how do we fix this mess? Well, the answer is to get the AI to stop thinking in scattered notes and start thinking in connections. Kind of like one of those detective corkboards with all the strings and photos, or a really detailed mind map. And this is the really big idea. Instead of just storing a jumble of facts and waiting for a question, we actually organize them first. We build a structure for that knowledge before anyone even asks anything. So it all starts with something super simple. The AI reads a basic fact, like Jay-Z is the spouse of Beyoncé. But, and this is the key part, instead of just storing that sentence, it turns it into a connection. It sees two things, or entities, Jay-Z and Beyoncé, and it understands the relationship between them, spouse of. Now imagine doing that for millions or even billions of facts. What you end up with is this incredible interconnected web of information called a knowledge graph. It's basically a digital brain, and this is the absolute core of GraphRag. So this digital brain, it's not magic, right? It doesn't just appear. It's built piece by piece through a really deliberate process that takes all that messy, chaotic information and turns it into something organized and structured. And here's how that works. First, you just gather up all the raw data you can find. Documents, websites, you name it. Then, the AI goes through and automatically picks out all the important stuff. The people, the places, the ideas. After that, it figures out how all those things are connected. And finally, it builds the actual graph, creating those nodes and edges we talked about. You test it, you refine it, and boom, you have this amazing foundation that a much smarter AI can use. Okay, now for the fun part, the payoff. What's the point of all this? What can this digital brain do that the old way couldn't? Well, this is where we go from a simple fact finder to an AI that can actually reason. Let's go right back to that Geoffrey Hinton question. Just look at the difference. On the left, you've got the standard RAG answer, basically just a bullet list of facts. He's a researcher. He worked at Google. Disconnected. But on the right, that's GraphRag. It actually walks through its knowledge graph and gives you a rich, complete answer that puts everything in context. It doesn't just list the facts. It synthesizes them into a real narrative. It connects the dots for you. This right here, this is the superpower of GraphRag. It's called multi-hop reasoning. And it means the AI can find answers by literally hopping from one piece of information to the next, following that chain of relationships. It's the difference between asking, who is Steve Jobs, and asking, how did Steve Jobs' design philosophy influence the iPhone? That's a multi-hop question. So GraphRag is a huge leap forward, no doubt. But it's not the only game in town. There's a totally different approach that's also gaining a lot of steam. Instead of building that structured brain, some new models are just being built with an absolutely gigantic memory. We're talking about 1 million tokens. That's like being able to read 2,500 pages of a book, all at once. The idea is to find the answer just by using brute force, by having a massive scale. So this sets up a really interesting choice, right? You've got these two paths. Graph RAG is like having a perfectly organized library with a perfect card catalog. You know exactly where to look. The large context models, that's like having a librarian who's a speed reader on steroids. For every single question you ask, they just read the entire library cover to cover. One is about clever structure, the other is about raw, brute force memory. But, even with Graph RAG, the work isn't done. The next big challenge, the next frontier, is making these digital brains dynamic, keeping that knowledge graph constantly updated with new, real-time information. It's a hugely powerful idea, but man, is it complex and resource-intensive to pull off. And that leaves us with the big question for the future of AI. To really get better at reasoning, does an AI need a structured brain that understands how things connect, or does it just need a bigger and bigger memory? The answer to that question is probably going to shape how all of us interact with these systems for a long, long time.